what really is code? Code is everywhere in our modern world, powering the technology we interact with each day. From the moment we wake up and check our phones, to using apps and browsing the web, to watching videos and playing games, code makes it all possible. But what really is code at its core? Code is a set of instructions. It's a specialized language that communicates to computers, devices, and machines how to operate. Code tells these machines what to do, processing inputs and outputs to make things happen. At the most basic level, code is just text. It's a series of characters like letters, numbers, and symbols that form words, sentences, and paragraphs. But unlike natural human languages, code uses these symbols to give very specific technical instructions. Code is translated into machine code, which is made up of binary, the ones and zeros that are the native language of computers. This machine code contains processor instructions that ultimately allow the software and hardware to function. So while code may look like abstract text to us, to a computer, it provides real executable instructions. There are many different programming languages that software developers use to write code, like Python, JavaScript, C++, and more. But they all aim to achieve the same result, telling a machine what operations to perform. The syntax varies between languages, but they share fundamental concepts like variables, storing data, values, operators, performing actions on data like math or comparisons, conditional logic, executing different code blocks based on conditions loops, repeating blocks of code functions. Reusable sections of code is modular and layered. A software program can contain millions of lines of code, all working together. Low-level code handles interfacing with the hardware and OS. Higher-level code uses frameworks and libraries to implement complex functions and UI. And application code ties it all together for the specific software behavior. This modularity allows developers to reuse and build upon code rather than reinventing the wheel for every project. Open source code libraries power much of the internet's infrastructure behind the scenes. Code follows key principles like being readable, reusable, and maintainable. Well-structured code is essential for software team collaboration and long-term maintenance. Technical practices like version control enable many developers to work on shared code bases. Code is also a creative medium. While it aims to be functional above all else, developers inject their own style into code. How they structure it, name variables, format it visually. Code contains clues about its author, just like any creative work, and programming itself requires creativity and problem solving. Developers must break down complex tasks into logical steps computers can follow. There are often many ways to code the same result, requiring judgment in which approach is best. This combination of logic, structure, and creativity is part of what makes coding such an engaging craft. Similar to other skilled trades like woodworking or baking, it balances technical precision with personal expression. Yet code remains invisible to most software users, quietly powering everything we do. We mainly notice it only when it breaks. For something so omnipresent, code can seem intangible, but we can glimpse code's physical reality in places like server farms. These vast warehouses contain racks upon racks of computers running code nonstop. The environmental impact of these facilities reveals how real and substantial code's impact is. Code has also become an integral part of our social reality. It shapes online interactions and mediates relationships. The algorithms curating our social media feeds are coded rules that influence how we get information. Code is no longer confined just to computers. It's embedded in our lives. As software continues permeating more aspects of life like appliances, vehicles, and cities, understanding code grows more relevant. It enables you to comprehend the forces shaping your everyday experience, but you don't need to learn programming to grasp code's significance. Just recognizing that our world relies on code built by people with biases and limitations is a start. Realizing that encoded software systems impact real lives can make you think more critically about the role code plays. The origins of coding offer perspective on how foundational it is today. The first coders were weaving punch cards to program looms in the 18th century French silk industry. British mathematician Ada Lovelace published the first algorithm for a computing device in 1843. In the 1940s, 6 brilliant women programmed the ENIAC, the first general-purpose digital computer. The term software was coined in this pioneering era of coding. Programming was considered clerical work and relegated to women until business interests recognized its commercial potential. As computers evolved from specialist tools to mainstream consumer products, coding grew exponentially in importance. Bill Gates and Paul Allen established Microsoft to sell software for the mass market. Apple marketed computers ready for the average person to use. The PC revolution brought coding from military and research labs to the desktops of millions. The internet age catapulted coding into the mainstream. From humble beginnings as a military network, the net became a digital universe underpinned by open source code. The web browser emerged as the interface making online information accessible to everyone. As broadband penetration fed demand for internet apps and services, hordes of amateur coders built websites, games, chat rooms, and more. Coding became a popular hobby and professional skill, no longer exclusive to formally trained computer scientists. The tech industry giants we know today like Google, Amazon, and Facebook leveraged the open internet and coding talent to become dominant forces shaping our digital lives. Their proprietary algorithms and massive code bases power our interactions with their platforms. Meanwhile, a new philosophy of coding emerged in the last decade that aims to put people over profits. The civic coder movement builds open source tools addressing social issues like economic inequality, racial justice, and transparency in government. Civic coding contrasts with much of the commercial internet, putting community needs before business motives. Programming languages themselves also evolved enormously since the introduction of Fortran in the 50s. Dozens of languages have aimed to make coding more accessible, efficient, and scalable. New languages like Rust and WebAssembly continue pushing boundaries today. Developer tools advanced in parallel to manage exponentially complex code bases. Version control systems like Git revolutionized software team collaboration. New frameworks and code libraries enabled faster development by reusing proven code. Automated testing and continuous integration improved code quality and deployment speed. This Cambrian explosion of languages, frameworks, methodologies, and infrastructure spawned entire new species of professional coding roles and specializations. The field diversified beyond its roots into numerous niches and hybrid skill sets. Today, coding drives innovation across every industry. It's the connective tissue integrating fields, enabling new breakthroughs at their intersections. Coding is reprogramming the limits of what's possible. Machine learning and artificial intelligence rank among the most transformative applications of code today. Training algorithms on big data unlocks insights otherwise inaccessible to the human brain alone. The raw material powering AI is masses of code, transforming abstract data into actionable intelligence. As coding becomes ubiquitous, basic programming skills are more relevant for everyone. Just as language literacy became essential for modern life centuries ago, computing literacy is vital today. We don't need to become experts, but should grasp coding's capabilities and consequences. Learning some coding fundamentals unmasks the magic of technology, revealing the mundane realities underlying it. Debugging your first program shows how brittle and temperamental code can be. You gain empathy for developers wrestling with hard-to-solve bugs in complex systems.